Good evening. Now we are going to see the shape functions for 2D element, where we are going to consider rectangular element. And again, by using Lagrange polynomial. So we are, this is third part of Lagrange polynomial, Lagrange shape functions. So we have two-dimensional element, four-noded rectangular element we have taken. Now in this, we are going to consider zeta and eta axis. So we are considering four nodes. So we have origin. At this point, we have this origin that is 0, 0. Then four nodes. So we have these all nodes at one unit from both the axes. That is from zeta axis also and eta axis also. So we have unit of first node. So we will say this is first node, minus 1, 2, we have 1 minus 1, 3, we have 1, 1, and 4, we have that is minus 1, 1. This is fourth one. So we have these four nodes, we are going to connect by elements and we will get a rectangular element with four nodes and values we have that is minus 1, minus 1, 1, minus 1, 1, 1, minus 1, 1. So now if we will switch over to shape function, so now we are at node 1. So we have these values and now we are interested, this is my first node, we are interested to find the shape function values for 1, that is at 1, then at 2, at 3, at 4 we can find likewise. Now for 1 we can say we have two elements. One we have that is element 1, 2 that is in zeta direction, element 1, 3 that is in eta direction. So we have to write two values, one for zeta and another is for eta. So now we have this coordinate zeta 1, eta 1, zeta 2, eta 2 as per node number. We have given suffixes for this. So now if I will go to N1, so we have L1 zeta, I already mentioned, and then we have L1 eta. So we are going to get 2. Now I already mentioned we have 1, 2. So for k is equal to 1. So now we are finding this. So for k is equal to 1, if I will say, then we have that is zeta minus zeta 2. So we have zeta minus zeta 2. And then for 1, 3, then we have this will be k is equal to 1. So we have eta minus eta 4. So we have to take 1 for here over. And we are finding for 1. So we should not have value of m should not be equal to k. And then below we have zeta is replaced by zeta 1, eta is replaced by eta 1. So second term we are as it is. So we are in the same fashion. Instead of single line, we are using two line because we have two dimensional, one along zeta and one along eta. Now to find the general equation for this n1, so we have to substitute values of zeta 1, zeta 2, zeta 2, eta 4, eta 4. Those values of coordinates we know, we will put that values. So our n1 will be proportional to zeta and n1 is proportional to eta. Now we have value of zeta 1 minus 1, we have value of zeta 2 1, sorry eta 1 we have minus 1, zeta 2 we have 1 and eta 4 we have 1. Now we will substitute these values and from this we will get zeta minus zeta 2. Zeta 2 is 1. So we have zeta minus 1. So we have zeta minus 1 and eta minus 1. Both we have 1, 1. So we have that will be minus 1, minus 1. Then below we have zeta 1 minus zeta 2. Zeta 1 is minus 1. Zeta 2 is 1. So minus 1, minus 1. Eta 1 is minus 1. Eta 4 minus 1. And from this we will get n1 as zeta minus 1, eta minus 1, minus 2, minus 2. Denominator get plus. We will take minus common from this term, minus common from this term. So we have minus 1 minus zeta and we have into minus 1 minus eta. And then we will get this as 1 by 4, 1 minus zeta into 1 minus eta. Because we have minus minus, we are going to get it as plus. And this is my general equation. Now, if I have to find at any point, then we have to put value of zeta and eta over there. So likewise, we have to find shape function for node 2, for node 3, for node 4. So now we will see it. So now for node 2, so we are in the same fashion. Node 2 means we have this. So we have to go with zeta direction 1 and we have for eta direction 3. So what equation I will get? Then I have zeta minus zeta 1 and then eta minus eta 3. So we can have zeta minus zeta 1. So that is in zeta direction. And then we have eta, that is eta minus eta 3. So we are in this one. So now denominator z is replaced by z2, eta is replaced by eta 2 because we are finding for node 2 and we are being in this fashion. Now we have to substitute value of z1, z2, eta 2 and eta 3. z1 minus 1, eta 2 minus 1, z2 we have 1 and eta 3 we have 1. And then we will substitute it. So from this we will get zeta. Now zeta 1 is minus 1. So minus of minus 1 we will get plus zeta 1. Eta minus eta 3 is 1 only. Then we have zeta 2 minus zeta 1. Zeta 2 we have 1 minus of minus 1. So again zeta 1 that becomes plus 1. Eta 2 minus 1 and eta 3 we have 1. So minus 1 minus 1. So now we have this value 1 plus zeta. We need not require to take anything common. And in this we have to take minus common. So into bracket minus 1 minus eta. And below we have 1 eta. That is minus 2. So this becomes 1 minus eta minus common. So it becomes 1 plus zeta and 1 minus eta. Because if I will take minus common from this, it becomes 1 minus eta. And this minus minus gives plus. We are going to be n2 in this fashion. Now if we will go to node 3, then we are in this fashion. Now for node 3, so we have, so if I will go to node 3, then we have 4 and 2. So we have zeta minus zeta 4 and eta minus eta 2. And then below z is replaced by z3, eta is replaced by eta 3. Z1 we have 1, but we need not require Z1. Z3 is 1. Eta 2 we have minus 1. Then Z4 we have minus 1 and eta 3 we have 1. And then we will substitute the value in the same fashion. Now we have all plus. So 1 plus zeta, 1 plus eta, and that is by 4. This is value by n3. And then we have last for n4. So when we will go for n4, so we have this will be 4. So this will be node 3 for zeta, and for eta we have node 1. So we have eta minus eta, eta minus eta, zeta minus zeta 3 and eta minus eta 1. So we can see this. So likewise, and then zeta and eta are replaced by 4. So zeta 4 minus eta 4. And then substitute these values and we will get this equation that is in this fashion. So we have, now just I will show you. So we have again, we will write this term minus in bracket 1 minus zeta. This minus minus become plus. So 1 by 4, 1 minus zeta, 1 plus zeta. So likewise, we have to go for shape function, that is rectangular element, by using Lagrange method. So now we will stop here only. Thank you.